So the directions say to write them with positive rational exponents. So rational exponents is fractions, final answer, they have to be positive. When I see a cube root, that means a 1/3 power. When I see a square root, that means a 1/2 power. Then we're using properties of exponents. If variables are divided, what do you do with their exponents? Subtract them. 1/3 minus 1/2 is -1/6. But the final answer, it has to be positive, so a negative power just moves it to the denominator. So 1/x to the 1/6. Number 2, we have the 4th root of y all to the -3rd. So a 4th root is a 1/4 power to the -3rd. A power to a power, you multiply those. And then again, it's a negative exponent, so final answer gets moved to the bottom. Okay. So number 3, we have a square root. A square root is what kind of power?
Oh, 1/2.
1/2, yeah, because we don't have an equation. If it were equal to something, we would square it to solve. But we don't have that, so we just have to simplify what we have. Inside here we have x squared times. A cube root is what power? 1/3. Make sure if you miss any of these, you're fixing them. When you multiply these x with these exponents, what do? Add. The x is written each time, so we add exponents. So 2 plus 1/3 is 7/3. Then we have a power to a power. In that case, we multiply. 7/6 is positive, so we don't have anything else we have to do. Number 4. Cube root of z to the 4th times the square root of z. So if we write these as fractions, cube root of z to the 4th is what power? Square root of z is what power? If you are multiplying, what do we do with our exponents? Add, because the z is written each time. So 4/3 plus 1/2 is 11/6. That's positive, so that's our final answer. So what I'm asking you to do on these is change your radicals into fraction exponents, use your properties of exponents, and then make sure at the end it's a positive. So move it to the bottom if necessary. Are those okay? Let's look at problem 10. So a couple issues that I noticed when people were working this. A 2/3 power means the cube root of x squared. 2x to the 1/3. Is the 2 under the cube root on this? No, it's 2 times x to the 1/3. So it's 2 times the cube root of x. I'm going to go ahead and subtract my 3 over. So we had people that were wanting to cube here, but they were trying to just go in and cube each number. Does that work? No, you have to cube the entire side, which means writing it 3 times and multiplying it out. So that's going to be pretty time consuming. But if I look at this, under my radical I have an x squared, an x, and a constant. So this is like a quadratic. So we can factor it like a quadratic. So cube root of x squared would break into cube root of x. I need 2 numbers that multiply a -3 and add to +2. Okay, so then if you set those equal to 0, you get the cube root of x equals -3, and cube root of x equals +1. The opposite of a cube root is cubing. Cube root cube, those cancel. -3 to the 3rd is -27. Here if we cube, we get +1. Make sure on these problems you always need to check. You can do it on the calculator, you plug them back into the original, make sure they work. They do both work, but if you type it in like this, you're not going to get it to work out. What's wrong with that? When I put in my negative 27. Yes. If you're putting in a negative, make sure you put parentheses around it. Right, so a couple people I know asked me if the 27 worked, and it was just because they didn't have those parentheses that they had a problem. Well. How do we get rid of square roots? So if I square each side, that cancels this square root on the outside, cancels this one. We get 2 square root of 7x plus 2 equals 3x plus 2. Now to get rid of the square root, we can square again. On the left, when I'm squaring both parts of those. So 2 squared is 4. Square root of 7x plus 2 squared just gives me 7x plus 2. On the right, what would we have to do? FOIL. We have this whole thing twice. So if we multiply out, we get 28x plus 8 equals 9x squared plus 12x plus 4. Set it equal to 0, so 9x squared minus 16x minus 4. So then we do our slip and slide. What multiplies to negative 36 and adds to negative 16? Divide your 9 back. So we get x minus 2. 9x plus 2. This will 0. Set those equal to 0 and we get positive 2 and negative 2 ninths. And then again, make sure you are checking. Okay. Again, on this problem, they do both work, but make sure when you put in the 2 ninths, you put it in parentheses because it is a negative. All right. Is there anything on those first 14 questions, 1 through 14? Anything else that you need that I have not gone over? Let's look at our next one. And that's kind of all the chapter 5 stuff that we covered. So the rest of this is from our chapter 6. Number 15, I just told you to decide if it's 1-to-1. And so you really have 3 options. The algebraic way is doing f of a equals f of b. So you add your 6. Divide by 2. How do you get rid of a square? And anytime you add a square root, you have to add. And as soon as I get that plus and minus, I can say these are not 1-to-1 because I got 2 options. If you want to think about a graph, we know x squared is a parabola. You know, this parabola, the 2 is just making it skinnier, the plus 1 just moves it left and down. But ultimately, we're still getting a parabola. And if you look at that, it fails the horizontal line test. Remember, if something fails the horizontal line test, that means it's not 1-to-1. So you could do it the algebraic way. You could do it the graphing way. You could also just tell me, what have we talked about with these? Is there a way to look at that equation and know? Yeah. We have said even power means it will not be 1-to-1. Because when you solve, you get the plus or minus. Or when you look at the graph, it always fails that horizontal line test. So even if you just told me in words, it has an even power, so it's not 1-to-1. That's fine. I don't care which of those methods you choose. But you have to tell me something. Don't just say yes or no. Justify your answer in some way. What does this mean? we needed one-to-one functions when we were finding inverses. So if it's not one-to-one, it means we can't find the inverse.
So you mean we're not getting points for being popular and good?
No, I'm a little more stingy with points than that. We can't find the inverse because y's get repeated. So when we try to find that inverse, it wouldn't be unique. Then it looks like we asked about all of our inverse questions. I don't know if that's really because we needed them or because it's towards the end of the study guide and you guys didn't finish it. But make sure, these are high point value questions. When we went through these, we had 4 steps. Step 1 was change f of x to y. So if I replace that, step 2, switch x and y. So if I do that, I get x equals 4y minus 5. Because that's what an inverse does. It flips x and y. Step 3, we're trying to find the equation. So if we want this, we need to solve for y. So we get y equals 4x minus 5. Oops, no, I just switched it back. How about we actually solve that? So if I add over my 5, x plus 5 equals 4y. You can divide by 4, so x plus 5 over 4. Step 4. Most of you are not doing this, and you will lose points on the test. What did I tell you to do at the end?
F of x of negative 1 equals...
Instead of y, write f inverse of x. That just puts it back into the function notation, but that negative 1 is denoting that we found the inverse. Domains and ranges. Because x and y flip, the domain of the original is the y of the inverse. The y of the original is the x of the inverse. If you look at your original, things we think about with domains. If it's a square root, it has to be a positive underneath. If it's a fraction, the bottom can't be 0. So when I look at this, I don't have a square root and I don't have a fraction. So what's my domain? Okay. The range of the function. That's harder to tell, but we can look, it's the same as the x of the inverse. This is a fraction, so the bottom can't be 0. Does 4 ever equal 0? No. Make sure you are fixing any mistakes you have. Monday, I am collecting these study guides. Problem 18. So step 1, instead of f of x, we write y. Step 2, we switch x and y. Step 3, we're solving for y. So you can multiply over your denominator. So we get xy minus x equals y plus 2. If I want my y's on the same side, we can subtract over this y. This x doesn't have it, so I'll move it over here. So xy minus y equals 2 plus x. What can you do at this point? They both have y, so if you take it out, then to get y by itself, we can divide. So y is 2 plus x over x minus 1. Am I finished? No. Instead of y, put it back in function notation. F inverse of x. No. Domain of the function is range of the inverse. Range of the function equals domain of the inverse. Looking at the original function, the bottom can't be 0, so x can't be 1. So just near infinity to 1, and then 1 to infinity. Find the range of the function, we look at the x of the inverse, can't be 1. So it's the same thing. Questions? I know a lot of people thought they got this one wrong because the inverse and the original function are the same. Doesn't happen very often, but if your original function is symmetric across the line y equals x, it is its own inverse. So it's rare, but it can happen. So number 19, first step. Instead of f of x, we write y. Then what do we do? So my y becomes an x, my x becomes a y. Now what? Trying to solve by y, or solve for y, so first we get rid of the fraction. 3xy plus 2x equals 1. If I want y by itself, we can subtract over the 2x. Now I have x times y, so we divide by x. You might have had it written differently if you divided the x at the beginning instead of distributing. So if you had 1 over x minus 2, that's equivalent. So final step, instead of y, we put f inverse. Domain of the function is range of the inverse. Range of the function is domain of the inverse. Looking at my original function. It's a fraction, the bottom can't be 0, so x can't be negative 2. So negative infinity to negative 2. Union negative 2 to infinity. Range of the function is the domain of the inverse. So if I look at that, the bottom can't be 0.
Well, wouldn't that just be 1, basically? Wouldn't x equal a real number, basically? Or?
So if you think about what we're doing, it's always the denominator can't be 0. So that's how we get x can't be negative 2. If you look over here, the denominator is just x, so we just get x can't be 0.
Okay.
Good questions. Make sure, if you are struggling with those inverses, you want to review them. I'm happy to give you some extra problems, but those are worth quite a few points by the time you go through all the steps of finding the inverse and doing your domains and ranges. So you need to make sure you understand those. Let's look at problem 20. What was our strategy on these problems? Trying to get our common bases. So our bases are 2, 8, and 4. What can I turn them all into? 2. Okay, make sure you're changing the right thing. So I have some people that are trying to make this 2 cubed to turn it into an 8. What you're doing has to be equivalent to the original problem. So I can rewrite my 8 as 2 to the third because 8 is 2 to the third. Okay, I'm not adding anything extra to my problem, I'm just rewriting it. I can change my 4 to 2 squared because 4 is 2 squared. So we multiply those exponents. If these 2's are multiplied, what do we do with the exponents? And when you do that, the base doesn't change. So negative x plus 1 plus negative 3x, negative 2x plus 1. Okay, notice, I've carried my base through this whole problem because the property says you can drop the base once it's one of them on each side. So I had to get it to just a single base on each side. Now I set the exponents equal. Negative 2x equals 1. And x is negative 1/2. And you can check your answers on these, but you shouldn't get answers that don't work, unlike the radical problems. It's when you start adding squares and cubes to the problem that you might get extra answers. These should check out, but pretty easy to plug in and verify. Yeah, Blake?
When you calculate 2 and then the exponent's negative 2x plus 1, before you added those, I dropped the 2 and had x plus 1 plus negative 3x, and I got negative 2x equals 1.
Yeah, I did
Yeah.
that too. I just
You
did-
guys just dropped it technically a step before the property says you can.
I
But
just wondered about
you did recognize that those exponents were added, so that's okay. The problem is I have some people that are trying to drop it here, and if they just drop it without thinking about it, they're multiplying those exponents, and that's wrong.
it.
So as long as you recognize that they're added together, it's okay. Other questions? Two. We want a common base. There's really two different options for how to do that. Option 1 is to recognize a square root is what kind of power? 1/2. So you could write it as 3 to the 1/2. Option 2 would be to say, okay, if I want to get rid of that square root, you could square both sides. Okay, that 2 would get multiplied with my exponent, so it becomes an 8x squared plus 2x equals 3. So either one is fine. Which one do you want me to work with?
I did the one on the left.
One left, okay. So now we can set our exponents equal. So we can subtract over the 1/2, bless you. Again, we have a couple options. You could, if you want to get rid of your fraction, multiply everything by 2 at this point. You could also have gone just straight into slip and slide there. But let's do this. That's what you would be at if you had done this problem, because that was 3 the first. So you would get to the same point. Now if we do slip and slide, multiply -8 and add to +2 would be +4, -2. Slide the 8 back. And if we set those equal to 0, you get -1/2, +1/4. What about that problem got you guys?
I forgot to do the bottom.
Just didn't finish it.
Can you just go ahead like from the and do slip and slide?
You can. Technically, okay. Yes, it gives you the correct zeros. Technically, the factored form wouldn't, or if you FOIL it out, you wouldn't get back to this, but you get the same zeros at the end, so it's okay. Other question? Let's look at 24. So these fraction bases have seemed to cause a few more problems. Our strategy is still to get a common base. When I look at 81, I know that is 3 to the 4th. 16 is 2 to the 4th. if I'm trying to make it match this 2/3, I can't just do 4. What would I have to do? -4, because I need to flip it. You could have also done this 3/2 to the -1 and 3/2 to the 4. That would work. So we get 2/3 to the x minus 1 equals 2/3. Power to a power, you multiply. So -4x minus 4. Once you have a common base, then you can set your exponents equal to one another. So if I add my 4x over, I get 5x. Add over my 1, it's -3. Divide and you get -3/5. Again, you can always check just by putting it into the original. Is that one okay? So on 25, these are inequalities. And I told you as long as you change them to a base bigger than 1, you can solve it just like the equations. If the base is less than 1, it flips the inequality. So you can certainly do it, but you have to remember to flip your inequality. When I look at my bases, 32 and 16, those are both powers of what number? So 32 is 2 to the 5th. 16 is 2 to the 4th. So with those exponents, power to a power, we multiply. Since my base is bigger than 1, I can just drop the exponents and keep my inequality as it is. That's why we want that base to be bigger than 1. So if I add over my 4x, divide, I get x is less than or equal to 4/9. If it's an inequality, the expectation all year has been to put it in interval notation. So less than means smaller than 4/9. So it's -infinity to 4/9 equal to tells me bracket.
If it wasn't greater than 1, would that be that to flip this one?
Yes. So if for whatever reason, like you had a 1/2 to the 5x less than 1/2 to the 4 minus 4x, when you drop the base, the inequality flips, and then you just solve it like normal. Let's look at 26. So, another inequality. We have to figure out what base to use. So we can do 5 or we can do 1/5. If we don't want to worry about any extra tricks later, just go with the base bigger than 1. So a cube root of 5 is 5 to what power? And 1/5 is 5 to the -1. So power to a power, you multiply. That's -1/3 x or -x over 3. It's less than 5 to the -x minus 2. Since my base is bigger than 1, when I drop it, my inequality stays as it is. I add over my x, I get a positive 2/3. I'm just going to multiply the 3/2. Yeah, x is less than -3. Less than, so smaller, no equal to, so all parentheses, so -infinity to -3. multiply or divide by a negative, it does flip the inequality. $27, last one of these. So I can use a base of 5/3 or a base of 3/5. You'll get the same answer either way, but if we don't want any extra tricks, let's do the base bigger than 1. So let's keep the 5/3. I know that 9 is 3 squared and 25 is 5 squared. But if I need the 5 to be on top, that means it would be 5/3 to what power? -2. The negative would flip. 5/3 to the x. Multiply those exponents. So -2 times 1 is -2. -2 times -5x is positive 10x. And we drop our base. Subtract over my 10x. If I divide by -9 though, what happens? Flips the inequality, so it becomes x is less than or equal to positive 2/9. So negative then means 2/9 with a bracket. Are there any other questions about the exponential equations or inequalities? Last thing was interest. On problem 28, you can't just tell me a plan. You have to have work to justify it. So we know that we have $40,000 to invest. What is that $40,000? For 3 years, so that is my time. Then I have 2 different plans. In plan A, my rate, 0.5% would be 0.005. Quarterly is how many times a year? 4. So it's the compound interest formula. So it's A equals P 1 plus R over N to the NT. So if I calculate that, my P is 40,000. 1 plus 0.005 over 4 to the 4 times 3 power. Everybody plug that in.
Is 0.05 the same as 0.005?
Because it was like 0.5% turns into
I
0.0.
understood it as 0.05.
It would not be the same because it was already 100% and you change it to this number because I'm dividing it by 100, so it makes it
Right. So it's like, okay.
So you get $40,604.14. Then we look at Plan B. That one our rate is 0.4%, so that'd be 0.004, compounding continuously. So that's the PE to the RT formula. So we have 40,000 E to the 0.004 times 3 power. $40,482.89. I want to know which one would be the better option. If you're investing money, You want the most return you can get. Which one will give you more money at the end? Plan A. So Plan A is the better option. If I were taking out a loan, which one would I want? Plan B. If you're borrowing money, you want to pay back the smallest amount possible. So you have to think about the context of the problem there. Last question, problem 29. So this one tells us, in 72 months, you must have $12,000. That means the 12,000 isn't right now, it's in the future. So that is the A. My time, I don't want to say 72 because 72 is in months. Time always has to be in years. So if you divide that by 12, that's 6 years. What amount invested today at 1.7%, so move your decimal back to 0.017, compounded monthly, so number of times a year would be 12, will give us that. So this time I'm looking for the P. I need to know what I have to have today. Easiest way is just to go ahead, put it all in the calculator at once so we don't have rounding error. If I want to get P by itself, we have to divide. So I'm just going to type it all in. You should get $10,837. 0.136, so that would round up to